Welcome back to another episode of This Is Fine, your favorite podcast where we navigate the tech and cybersecurity landscape in the world of government with questionable grace but lots of enthusiasm. I'm Matt Triner, your host and CEO of Hunter Strategy, and today we're diving headfirst into the somewhat interesting waters of time in software, infrastructure, and security. Buckle up because we're going to have a trio of time-tackling titans joining us today. First, we have Michael MC Christofferson, our very own senior DevSecOps engineer. Next, we have our one and only Matt DiVertola, our director of AI solutions and senior DevSecOps engineer here at Hunter Strategy. And last but not least, the master of time, software engineering, and all things whimsical, the director of software engineering himself, Greg Venor. Now, time is a fickle friend in the realm of software infrastructure and security, so let's not waste another second and jump right into our questions for today's roller coaster of a discussion. So, to start off, when I think people that have not dealt with strange time issues in software are going to hear this, they're going to think when I say time, I mean like level of effort or amount of time it takes to do a thing. And that's not what I mean at all, although certainly we've talked about that plenty with the death spiral and agile concerns and lots of other things that have to do with time as an expression of level and effort. But in this case, we're referring to that thing that Einstein said has matter, the actual passage of time and how it's recorded and what that means. Since Greg is our resident guru of the whimsical concept of time, why don't you give a little bit of a level set, Greg, as to like what we're referring to when it comes to time in software?
Sure. Well, what we're really referring to is making your software align with the completely invented by human concept of time. And that is really difficult because time zones, for example, aren't actually real. They're defined by politics, not even necessarily by politics. In the US, time started, so the differentiation into time zones kind of started with railway time. And I'm sure some historian is going to tell me I'm wrong. It probably goes back to the East India Company and other stuff, like when these massive companies had to figure out how to coordinate their activities around the world. And so those things have changed over time, and even now they're changing. Like you hear a debate of whether we're going to have daylight savings time or not. You know, that changes what the meaning of time is, and your software has to deal with it. And if you asked me to create a software that said, with certain granularity, right? What time was this event, or how many hours ago was this event, and it was like 120 years ago. That might actually be difficult to do because you need to know the political changes in time zones over that time as well, plus the geography. So there's this whole geo thing going on with time as well. And then you have the secondary issue when you're doing distributed systems and security. You need what's called a monotonic source of time, that means something that never goes backwards. And if you are using normal system clock time in your application, then you have problems where an update to your NTP server might move your clock backwards. So you can get into big trouble if your algorithms are relying on system clock time, which means you need a different source of time. But there's no way to coordinate that between all your servers, which means how do you actually deal with having things synchronized on the basis of time in your software? So that's my overview of the political and the technical issues with time. Not even getting too big into the whole like calendaring and collaboration and those sorts of deals with like dealing with figuring out all those differences. Like, fun fact, I'm sorry to keep going, but like the safest hour in the universe, in the world for driving, is that transition from non-daylight savings time to daylight savings time and back, because it basically creates an hour where nothing happens because the suddenly time moves. And if you look in the stats, like car accidents go to zero for that hour, but it's an illusion, right? So anyway, that's it for my intro.
So and you mentioned a bunch of examples, and daylight savings time confounds people when you're not dealing with systems. But so what are the reasons why having a synchronous way of, or synchronicity is the word I just introduced accidentally. I don't even know if I meant to do that. Having a universal way to describe time is important. Like when uh, and anyone can take this. Like, why is it important that we describe time in a uniform way, and what happens if we don't?
Yeah, so I can talk about that from the security perspective because I deal a lot with log ingestion and correlating when did this event happen versus a different event. If you are if you have lots of log events generated by applications like Greg was talking about various applications, and a security team needs to review those logs. If we don't very carefully say, okay, this log logs in UTC time, and we're going to ingest it into a system as UTC time. You know, that log might actually be in Eastern Standard Time, and then I ingest it into a system that's running in Eastern Time. And if that system assumes logs that it ingests are Eastern Time, now all of a sudden all of my times have swapped an hour. And then if the end user is looking at it, and in a different time zone, if they can change the application that views it to say, hey, show me this in Central Time, you've already done like 3 time zone conversions to those logs without realizing it. And then as a security engineer, if you're trying to say, okay, we saw some weird activity at 7 a.m. this morning, uh, what users were logged into the system that could potentially do that, and I go look at our security events from 6 a.m. to 7 a.m., and I only see, Matt Triner logged into the system, but really I need to be looking at a different set of hours because those logs got logged in a different time zone. It can get really convoluted really quickly unless all of these things are being accounted for when the log is getting logged, the logs getting ingested into a security monitoring platform, and then the security analyst who's looking at it knows that either by default these logs are going to be in UTC time, or I know that I have my UI set to change it to my time zone, but the source of truth is UTC. So it can become extremely complicated really fast from a mean time to resolution for diagnosing a security event if you're having to correlate logs across different time zones really in trying to do it fast, unless you've designed your system from the ground up to handle all of those different time zone conversions and the way things come in.
And what are some examples of, like, so we've talked about logs,
Yep.
right? But like, what are some other examples in infrastructure that can be affected by having time not being properly represented across distributed system, multiple systems, even just a system that's not distributed but is being load balanced with multiple instances? And they need to kind of coordinate time. What are some examples outside of logging? And all include incident response, because you kind of covered that as kind of a secondary function of like why we have logs. And you can certainly, like, if we had Jake or some folks from our security team on here, they could share some really terrible stories when you realize that the time stamps in the systems that you're looking at are not uniform, and there's just a whole lot of work in converting them to be able to create a reasonable timeline in a forensic investigation. But like, that seems, I don't want to say that's table stakes because that's super important, but like, that seems obvious to me, right? Like, yeah, if you don't log your time right, then the things that you use your logs for, which is like troubleshooting or dealing with an incident, are going to be harder to do, right? And like, might not be so trivial to fix. And we'll talk about kind of what to do later. But like, what other things other than logging are really time sensitive?
I got two for you. We've actually seen this, or I've actually seen this, but we have, for example, here an application that uses zero trust architecture. And the way that works is everything uses mutual TLS, and every service it gets its own server certificate generated for it. And then there's a policy table that says what services are allowed to cross communicate with each other, so that the services only trust the ones that are expected to communicate with. And so one thing that kind of happens on some servers is that when you get really high CPU use, this interesting thing happens where the clock can drift on the system unless it's resynchronized with the NTP server. So you'll see like some servers, they configure the NTP sync to NTP is the time protocol for those who don't know, network time protocol. So they configure the NTP sync to happen like, I don't know, every 5 or 10 minutes to try to keep it from skewing. But if you haven't done that and you have a system that has this issue of clock skew, you'll get into an environment where all of your services will stop talking to each other because part of the TLS handshake is a valid time period for when that handshaking process is valid. So basically, like the client says, here's my private key bits that I'm going to sign, and when you're going to verify with my public key, and I signed them at this instant. And then the server goes and reads that, tries to verify the signature, and the server says, yeah, you signed this 5 minutes ago, even though it may have been 10 milliseconds ago. And then the server says, I can't trust this because it's too old. Try again. And everything stops talking. That's one. And then my other one is in distributed systems, when you start working off of work queues and you're dynamically scaling your workers based on the things that land in the queue, depending on your implementation, if you require those items in the queue to be in time order of when they occurred, right? Then you have so if you can't guarantee that at the queue insertion level, like if the queue might not be ordered representation, then you're going to have to rely on something else to order the work tasks. And a lot of times what you can do is you pull it off into a delay queue and then you reorder them based on some timestamp that's in the message. But then you get back to that issue of if all of your servers are not synchronized and some of them are skewing, you might inadvertently reorder messages in the wrong order. And then that can mess up data integrity in your backend. So that's two for me.
Yeah, and I also have two examples. Both of them are authentication related. One, is just, Windows authentication, right? When you are authenticating, with your, Windows credentials or Microsoft Entra credentials, right? And your system time is off more than, I think the default is like 5 minutes. It allows you to skew. It just won't allow you to log into your domain anymore or into your environment. So making sure that your time is synced between your machine and the domain controllers that you're connecting to is extremely important. Again, they can be set in different time zones as long as they both realize the time zone differences. One thing that we always joked about, in the past is, your time can be off as long as everybody's time is off together. So if your NTP server is wrong, as long as everyone's using the same NTP server, at least you're all wrong together. And then the second example I'd have is, again, it's authentication related, is for SAML auth. We recently were, working with a application where the system time was running in Eastern time. The application was set to log in UTC, but for whatever reason, it stopped logging in UTC or operating in UTC time and started defaulting to the system time. The SAML tokens that it was creating to get signed, it was using what the application thought the time zone was, and then appending a text string to it that it was UTC time, whether or not it was actually UTC time. So that's a bad thing we're just going to push to the side completely regardless. So then when it reached out to the SSO server, the single sign-on server, to create its SAML token, it sent it with a Eastern time zone time that was labeled as UTC. And so the server just outright said, nope, like this isn't valid at all, and rejected it. And all authentication for that app, stopped working. And once we realized that was the problem, we were able to quickly, fix it. But yeah, there's just different for authentication and authenticating yourself into systems. They all rely very heavily on what time do you, when are you trying to authenticate, and then the service allowing you to say yes, you can get in is really important, because you don't want, there's so many systems, especially once you get into, STIG compliance or just all kinds of compliance frameworks, that, when you authenticate to a system, you can only be authenticated for 10 minutes. And then if you take some action, it can, refresh that timer. But you have to make sure you're only in the system for as long as you're allowed to be. And if your times aren't right, that can become massive changes.
Yeah, I was going to kind of jump in and echo that too. In that instance, we're comparing Eastern time to UTC time, right? So when you're saying, this is going to expire at UTC time and you're setting time now to Eastern, then you're going to immediately expire and you're just going to not have access to the system. But if you invert that and your server time is, say, on the West Coast, and your user is on the East Coast, and there's a 3-hour time difference, that user, may get their time checked over on the West Coast and be fined for 3 extra hours when they shouldn't have access to a system. So getting time right can, impact immediate availability, but also can give several hours of time where a user shouldn't have access to a system if your software implementation is incorrect. Yep. Which maybe Unix time is an interesting.
So for people that don't deal with this stuff all the time, what is Unix time? Why isn't it just time?
So the Unix time is the amount of seconds that have passed since 1970 in UTC time, I believe.
Milliseconds, I think, right?
Milliseconds. Okay. Yeah. The fundamental concept behind that is that you can set UTC time Unix time on any system, and it should effectively be all the same. Unix time can effectively be the same on any system at any part of the world. So everybody's kind of reading from that same sheet of music. But one of the not so great parts about Unix time is it is super ugly. It is just 10 numbers that usually start with, I think, 17 at this point. And human readability is impossible unless you read a lot of Unix timestamps. So it introduces kind of a different problem a lot of the times, especially if you look at log ingestion and log analysis of converting from that timestamp. You don't have that immediate human readable kind of format, which I think opens a whole can of worms on the other direction of problems that it can create as well.
Well, let's not get the Brits in here to talk about, month, day, year versus year, day, month, and all the other crap that we have to deal with. But I take it you're on team ISO 86501?
Yes, I am.
Well, then you get into all like leap seconds don't happen very often, but if your application is doing, very intensive things, Unix time is every second since 1970, except non-leap seconds. It doesn't count leap seconds. So
there you go.
Again, it's all fun.
And we have Y 2038 with Unix time as it's defined. Well, no, I think it's been solved, but I don't know how widespread the solutions are. For those of you who are not familiar with Y2K, back in the day, it was common in a database. You'd only store the last 2 digits of the year, right? You're born in 1965, 65. Then as the year 2K approached, people realized, well, hang on, we can't tell the difference between 2001 and 1901. And that was a big problem. And so similar issue that's called an integer overflow. Originally the Unix timestamp is a 32-bit number, and when it hits somewhere in the year 2038, it will overflow back to 0. And if you have not updated to 64-bit numbers by that time, everything will go haywire. If planes will fall from the sky and all of your credit card transactions will fail, just like what happened with Y2K, right?
Yeah. I do miss those yellow stickers at the Best Buys that said, make sure you have your computer turned off at by midnight on the year 2000.
I forgot about that.
I haven't seen them in a Best Buy for a while now, but I'm dating myself a little bit there.
And definitely turning it off and then waiting and turning it back on again was a very viable solution to and actually I think it's important that we take a second on Y2K just because one, although you just explained it, there are a lot of people of younger generation that don't know what that was. And then there are those that we seem to be in this kind of like post facto history era of the world where like, well, nothing happened, so it was fine. And I'm kind of thinking like nothing happened because we poured millions of dollars into rewriting databases and systems. And like, I don't know that I believed the hype that like a plane in the sky would suddenly start to crash because it had a time issue. Like, thankfully, especially back then, planes weren't so autonomous with systems that like I don't know that I believed that, or like that all the power would immediately go out, like, and all these different things. Like, I don't know if I believe the gravity that the media was pushing, but like your bank account getting erased was, I think, a very real thing that could have happened.
Oh yeah.
system access in a building, or building access and key cards and swipe cards and a lot of these like very database driven systems on some other UL standard that is very infrequently changing. There was a lot of work that went into it, and not just hacking and slashing. And I think this is kind of one of the things about time that gets overlooked is there was tons of engineering work that went into it, don't get me wrong, but I just remember all of the working groups and all of the draft publications on like how are we going to agree to do this, because to MC's kind of earlier point, like we can all be wrong so long as we're all wrong together.
Yep.
And that is, I think, a really important thing that gets missed, because even though some might say we don't handle time the best today, or we could do it better, or whatever, fair enough, right? I don't think that like all of our standards are perfect, and I certainly don't think that there are no ways to improve some of these fundamental concepts. But I do think that we got to an agreed concept, and it's been pretty widely implemented. And as we move into kind of larger open sourcey things, like as databases, I mean, at the time of Y2K, was there even an open source database? Like, did one exist yet? I'm not even sure.
Probably, but the first year of my career was fixing Y2K stuff, and it was all Oracle.
Yeah, it's Oracle or Sybase was pretty much like the
Yeah.
available things at the time. Certainly, you have like DB2 and Adabase and other things, but if you're talking about SQL-driven databases, it was Oracle and Sybase.
I mean, in that time frame, I was still using FreeBSD because Linux was unstable and not worthy of production. But yeah, so like the big Linux open source databases like MySQL, maybe they were around, but they probably were not trusted for actual use out there in the wild.
And so when we talk about kind of the work that went into it, and I think this, like a lot of other kind of fundamentals in system engineering, gets overlooked often, is that the conversations and the agreement on the convention is usually the much harder part than like actually doing the work, or certainly the much longer and more painful part. Harder is relative, and I'm not even commenting on that, but like it's interesting.
So I think I just want to. This is a great moment to pause, because just like you were saying, I would like to write a little love letter to the Unix timestamp, even though we just dissed it a minute ago. Because back in the day, when you stored a date, you'd have like characters, right? Like the problem was that you would have character field for the year YY, right? And you had to update that. And this was being interpreted in a very specific way. And you needed functions to convert, your character to actual dates. And there's different date formats. Do you have like YYMMDD or DDMMYY? And you basically do all this processing to interconvert. And the beauty of the Unix timestamp is that it is just a 32-bit number. And when you need to compare them, if I want to say, did this happen after this? I just say, is this number greater than this number? And I don't have to get into pulling this thing out and parsing it, figuring out, was that an Eastern time zone, YYM, MMDD, HHMM, SS time, and then parse that from string into some number and do all these conversions. Like databases like Oracle had all of these conversion and comparison functions for dates that let you put in your date formats and all this kind of stuff to figure out if things were after or before. And there is a beauty and elegance into just distilling that into a single reference point and a number.
So what are some kind of what are some other, we talked about Y2K a bit, but what are some other real life examples of time failing a major system issue?
I'm pretty sure the Boeing 737 Max software was a time related issue where they were crashing.
My understanding of that was there was a flaw in the system called MCAS, the Maneuvering Characteristics Augmentation System, which would activate at the wrong time due to partially faulty sensors, but also a lack of synchronization between MCAS and other systems on the Boeing and causing it to react effectively too quickly, which is what actually ended up causing a couple of those fatal crashes that were attributed to
Yep.
MCAS. So that's a really good example of when you're not in a distributed system, you're in a self-contained, fully wired environment, but the idea of time in most SCADA and ICS systems are very much like Unix time based, right? They're very much like on some relative measure of time that is self-contained to the ecosystem, so that any form of time drift will be consistent within that ecosystem.
Yeah, so each component on the Boeing is keeping track of its own time, and they just weren't exactly all aligned. So that would have been a good example where potentially if there was a NTP server on the Boeing aircraft itself that let all of the different components synchronize their time. Again, as long as they're all wrong together, but they just all agree on what specifically the time actually is, that may have been a component that could have helped there.
So there is an interesting a CPU feature that came out quite a while ago. I don't know exactly when, but it's called nanotime, and it measures time in nanoseconds. And this is really what you want to use when you are developing time-sensitive software, because it is guaranteed, is like we talked about earlier, it is monotonic and guaranteed never to go backwards. Like you will never get an NTP update that moves your nanotime reference point backwards. The problem with nanotime is that it is basically on a per execution basis. So you can't coordinate your nanotime across processes in your system, nor can you coordinate it across systems. So you still need other solutions like vector clocks if you're going to try to make a time-based distributed system. But within a process, nanotime is the way to go.
And so, speaking of processes and just generally how to make it the right way, what are some things that we can tell listeners that are software engineers, software architects, infrastructure folks, like how do you get time right? We've mentioned NTP a couple times. I think that's a solid recommendation to start off with. But what else is there?
Make sure you have observability and that you don't have clock skew across your fleet. That would be really important, because if you're a software developer, you can write your own algorithms, but if you're just deploying someone else's software, there's a very good chance they're just getting system time and using that inside their application, and you'll need to be as synchronized as you possibly can.
If you're an application developer, or writing some type of, if you're writing information out to log files or even to a database, make it so that what you're writing includes the time zone it was created in. Otherwise, everyone's just assuming what time zone that was.
Yeah.
Ideally, you set it to be UTC, but you still log that it was UTC.
Get it from your system. Don't make it per application configuration. Yeah. And if you are on Windows, I'm not sure if this is still an issue. Maybe, Michael, you know more about Windows than I do. I'm more in the Linux world.
Mhm.
But Windows has long had this problem where administrators like to set the timestamp, the time zone local to where they're at. And that has kind of migrated up to be the system time zone. And it gets all wonky really fast. Whereas like on the Linux systems that I work with, I can set my system clock and my OS clock in UTC. But my local user's time zone can be adapted to what I see in my own local time zone for display purposes. And so I've seen more problems on the Windows side than Linux side with time zone mismatch. But it can happen anywhere.
Yeah, that's my preferred solution, is just set the system, have your applications be UTC, and then the end user applications that are ingesting this data, they can have a per user setting to select the time zone they want the information displayed in.
Yeah.
But it's actually stored and logged as the universal time code.
If you need to process time for like calendaring and other kinds of human representations, use a well-regarded library.
Yes.
Like one that will handle time zones and leap years and leap seconds and all that crazy stuff.
Yep. Yeah, there is if you think you can do your own time library better yourself, you can't. Many have tried before you and failed. There is lots of hilarious documentation out there about it, but even the time database the well-regarded library that you use, just go look at changes to the time database, and there are very hilarious comments on it, like, for the time zone for Nepal, time databases had to change the skew for that time zone by like 5 minutes because they decided to change exactly how they're keeping things logged.
Time zones don't have to be on the hour basis either. They can be anything.
Yep. Yeah, I had to look this fact up because I couldn't remember, but currently there are a total of 245 time zones that are considered well-regarded time zones.
Mm-hmm.
There's 195 countries in the
Yes.
world. So
one of my favorite trivia questions is always how many time zones are in the US? And there's like you said, well-regarded, there's only a handful. But officially, when you make politically, when you make a distinction, it gets its own name. So like the Navajo reservation in Arizona has Navajo time because they're considered a sovereign nation, even though they align with Rocky Mountain time, which is interesting that they align with Rocky Mountain time because Arizona itself is Arizona Mountain time because they do not do daylight savings time like the rest of Rocky Mountain time zone does. So within Arizona, you have an enclave that does daylight savings time. Technically, it's a different name, even though people will say because it's referenced to the other time zone, it's not a different time zone. But if you just add up all the different actually named time zones, you get like 26 time zones in the United States, something like that. Like all those places where they make a special carve out for the time zone would, I think in some of our eastern central states, there's like the time zone carves through the edge of the state. And it would go through the middle of some of the big cities, but then they make a special time zone to represent the fact that the city's an exception to the line going through it. All kinds of wacky stuff is happening.
One of my favorite things that I learned when I was in India many years ago, because India is famously on the half-hour time block compared to others, and it was because traditionally in historic India, time was so specific. It was actually done per town, and every town had a sundial. And so it was the exact time of the sundial was the time of that town. And obviously that got untenable as, city states became counties and like larger and larger demographic areas. And as they got to a national concept, they were like, we're just going to take the line right in the middle of the country and like its quote unquote sundial position in the geographic middle, which is like, my understanding is not the actual geographic middle, but that's neither here nor there. But that's how they basically, it was this compromise of we're going to go to the centralmost point in the country because having the correct time was also a sense of pride among these city states. And when they kind of took that away to kind of align with another country's time or another time zone was seen as kind of an affront to that historic reverence for time accuracy. So I always thought that was a really because I always knew on the map every time I was writing an application at a time, I'm like, oh yeah, India's got the half hour because they've got to do it. And I remembered being at a sundial in an ancient Indian city on a tour and them explaining this. And I'm like, oh yeah, that I don't fully understand the specific logic of it, but I can understand why that would be a really big deal to a lot of people coalescing under a single time. There needing to be more than just we took the time of our neighbors as the convention, right? And by neighbors, I mean neighboring countries, especially when geopolitically the neighboring countries in India at different times had different levels of wanting to align with anything. So yeah, it's interesting to see how and why. So I'm sure there's a good reason. I'm sure there's a reason why that tribe you mentioned, Greg, picked Rocky Mountain time and not Arizona Mountain time. I don't know what it is, but there's definitely a story there. They didn't just pick the other one.
Right.
So
Yep.
Well, there's even a more recent example of that where like the Samoan island, for whatever reason, they decided they wanted to be on the other side of the international date line. So on December 29th, 2011, at
Yep.
midnight, they decided to go actually to plus 13 hours. So they went from December 29th to, or sorry, from December 28th to December 30th.
Hmm.
December 29th, 2011 never happened for the Samoan island.
Yeah. Wow. And how
Like
many
that's the
hours
kind of stuff.
ago
Back to the
was?
time
Yeah.
library concept, right? Like,
Yeah.
can you imagine being that poor maintainer of like
Yeah.
one of those libraries and then finding that out and being like, God damn it! Like this
Well,
is going to be so much work.
I don't know that the libraries handle that, because pretty much what they do is there's like on Linux, there's a package called like TZ data, which is basically this huge database, open standard of all the time zone stuff to deal with, right? I don't know that it contains the history of changes in it. I think it might just be the current time zone data. And the reason that package updates all the time is because time zones are politically defined. Some country makes a law and says we're moving our time zone 3 minutes, and boom, goes into your TZ data package update. Does anyone remember the failed attempt for metric time in the 2000s?
I do
No.
not.
So the idea was that they were going to, because metric and SI is all divisible by 10, they were going to have 1,000 units of time in the day and subdivide that down to the single beats, and some, I forget how it worked out. It was something like each unit ended up being like 1.3 seconds. It was very weird, right? If you mapped it back, and they were going to completely do away with time zones. And so you could say, let's meet at 683, and it would be 683 everywhere in the world, and you would just come to know that, your waking hours were between these bands of numbers in your metric time. And Swatch made wristwatches that displayed metric time. You could buy them for a little while.
Yeah, that feels like another thing to confuse the libraries really
And
well.
given that it was the early 2000s, the way they notated it was with the at sign. So you would write at, 3-digit number for your time.
That's a new one. I have to look that one up.
Yeah.
So, as we come up on time, what parting thoughts would you want to give to people, incident responders, infrastructure engineers, software engineers? I think it's to can't help myself with the puns, but like don't skip time, right? Like that seems like a decent thought. But Greg, I know you got a better one. I'm curious for all of you guys.
Well, my general thought is that if you are writing a distributed system and you are relying on system time, you're going to have a bug. Period. Sorry. There's going to be a problem at some point. The question really is, how frequently are you going to see it? And if you can't use a vector clock, and vector clocks are hard, and I have not found a good, vector clock library that I can just say, oh, just go use this. But if you can't do some sort of interrelationship between your events to define the before after concept, and you have to rely on time to order your events in your distributed system, then at least keep a tuple of source node and system time so that you can correlate a clear delineation of order from a single node when you're processing. So you don't at least intermix things from the same node. I guess that's my
What about you guys?
I think my far less intelligent response to that is probably that all of your servers should be reading from this same clock, which should, in most cases, be set to UTC through and through. And then all of your software should be using Unix time. And I think that in most cases, like probably 90+% of the software that you plan to run on Earth, and not in space, that's a whole other thing we haven't really talked about. But if your software is planned to run on Earth, I think those two things are probably going to be your 80/20 or 90/10 on fixing most of your time related issues.
What about you,
Yeah.
MC?
UTC time, just standardize to it, and then make your application display for end users. But from a security incident response standpoint, don't take for granted that the logs are in the time zone you assume they are. Trust but verify is the way I would go about that, because it's going to save you a lot of time in troubleshooting and investigation and things like that. And if you're setting up a new system, or if you're integrating new log sources into a sim that you're working on, you're going to save yourself and your incident responders a whole lot of headaches if you validate that the time zones are being ingested properly. You might not have control over whether the end system that you're gathering data off of is actually in UTC or not, or whether that log is in UTC, but validate, okay, is the log file that I'm ingesting, what time zone is it in? And making sure that when you're ingesting it into your sim, it is being tagged properly. So when you're running your incident response, or just normal queries to make sure everything's still good, that you're looking at the right range of time. Because in a lot of those cases, you're not looking at just one log source, you're correlating data across many log sources, and if one of them's wrong, your correlation isn't going to be useful at all.
Well, with that, I think we're definitely going for a niche audience today, but I do think it's an important topic, and one that does not get the time that it deserves until we come back to have a full episode on space time. This is fine with Hunter Strategy. Gentlemen, thank you so much for being here today. Really appreciate it.
Thank you.